3, 2, 1.
A couple of days ago, SpaceX launched Starship Flight 7, the first ever mission that used a Block 2 vehicle. This mission, regarded as a walk in the park by many, was supposed to be another step in the company's ambitious efforts to develop a fully reusable spacecraft capable of carrying humans across space. However, unfortunately, the flight ended in a disaster that is far worse than anything we've seen in the past few months from SpaceX. So let's not waste any time and find the root of the problem imminently. But first, let's take a closer look at the flight itself. Starship Flight 7 lifted off at 4:37 p.m. local time, featuring Booster 14, a Block 1 Super Heavy booster with some minor changes, and Ship 33, the first Block 2 Starship upper stage ever to be used. Ship 33 was equipped with several upgrades, including a larger propellant capacity, redesigned forward flaps for improved aerodynamics and thermal protection, and an enhanced avionics system. The mission objective was ambitious: demonstrate the recovery of the Super Heavy booster using the launch tower's chopstick arms, test the deployment of 10 mock satellites, and evaluate the performance of the upgraded Starship upper stage during ascent and re-entry. The stakes were very high, not only for SpaceX, but also for the broader spaceflight community. However, it was achievable, as practically everything here has been done with the previous flights. As a result of this, a successful mission would have solidified the company's position as a leader in reusable rocket technology and brought humanity one step closer to interplanetary travel. Unfortunately, the results were a mixed bag at best. One of the mission's most impressive achievements was the successful recovery of the Super Heavy booster. 7 minutes after liftoff, the booster executed a boost back burn and landed back at the launch site with precision. Using the chopstick arms mounted on the launch towers, SpaceX caught the booster, marking only the second time this recovery method has been achieved, with the first time being Flight 5. This milestone is a testament to SpaceX's engineering prowess and its commitment to reducing the cost and turnaround time of rocket launches. However, while this feat is undeniably remarkable, it's worth noting that the booster recovery has become a staple of SpaceX's operations. The company has repeatedly demonstrated this capability with its Falcon 9 rockets, so the bar for innovation has been raised. It's fair to expect that such a mature feature of SpaceX's portfolio would be executed flawlessly. And while the success of the booster recovery on Flight 7 is undeniably commendable, it's not groundbreaking in the way it once was. Now, the true disappointment of this mission lies in the performance of the new Starship upper stage, which is Ship 33. Approximately 8.5 minutes into the flight, SpaceX lost all communication with the vehicle. Initial reports indicate that a fire broke out in the aft section of Ship 33, leading to a catastrophic failure and the disintegration of the spacecraft over the Turks and Caicos Island. This rapid unscheduled disassembly, or RUD, as SpaceX euphemistically calls explosions, resulted in debris falling over the Caribbean, causing temporary airspace closures and flight diversions. This failure is particularly troubling because it underscores persistent challenges with Starship's reusability. Ship 33's upgrades, which were intended to enhance its performance and durability, clearly fell short. While SpaceX's willingness to take risks and learn from failure is definitely a part of its innovative spirit, the loss of Ship 33 feels like a missed opportunity to demonstrate meaningful progress. After 7 test flights, one might reasonably expect fewer critical failures, especially when the stakes are so high. Now, the fallout from Ship 33's failure extended beyond the technical sphere, impacting commercial air travel in the region. Debris from the disintegrated spacecraft forced the Federal Aviation Administration, or FAA, to temporarily slow and divert planes, causing delays for dozens of flights. While no injuries were reported, the incident serves as a stark reminder of the risks associated with large-scale rocket tests. Ensuring public safety is paramount, and incidents like this highlight the need for more robust risk mitigation strategy. Now, in the aftermath of the mishap, both SpaceX and FAA launched their own individual investigation to determine the root cause of the failure. Preliminary data suggests that a fire in the aft section of Ship 33 was the primary culprit. The result of this is the FAA suspending all future Starship flights until the investigation is complete and corrective actions are implemented. Elon Musk, SpaceX's CEO, characterizes this failure as barely a bump in the road, emphasizing the company's commitment to learning from its mistakes. And while it is very refreshing to hear optimism these days, we really wouldn't put our trust into Elon and his overestimation and general hype about everything. The whole mishap raises questions about whether SpaceX's culture of rapid iteration sometimes prioritizes speed over thoroughness. The loss of Ship 33 is not just a technical failure, it's a public relations setback that could erode confidence in the Starship program. Now, the mixed outcome of Starship Flight 7 has broader implications for SpaceX and the future of space exploration. On one hand, the successful booster recovery demonstrates progress towards a fully reusable launch system, a critical component of SpaceX's vision for reducing the costs of space travel. On the other hand, the failure of the upper stage underscores the challenges of developing new technologies and the risk of pushing boundaries too quickly. That said, it's worth noting that SpaceX's iterative approach to development is not without merit. The company has achieved remarkable milestones by embracing a radical philosophy that relies upon rapid testing and learning from failure. This was a great experience gainer of an idea because, well, we all learn best from our mistakes, and because of it, scientists have already gotten a far better idea of the way Starship will work because of it. However, as SpaceX moves closer to conducting crewed missions, the margin for error, which was very high in the beginning, becomes much smaller. The stakes are no longer just financial or technical, they're human. Ensuring the reliability and the safety of the Starship system must be a top priority, and to be honest, at the moment, that's really not the case. Now, despite these admittedly massive setbacks, there are valuable lessons to be learned from Flight 7. The booster recovery success reaffirms SpaceX's expertise and reusability, and while the failure of Ship 33 is definitely tragic, it also highlights areas of improvement, whether that be the design of the vehicle itself or the operational reliability. Moving forward, SpaceX will have to address these issues head-on by refining its systems and processes to minimize the risk of future failures. One area that warrants particular attention is quality control. While SpaceX's philosophy of build fast, fail fast has definitely driven innovation, it also led to a perception that the company sometimes cuts corners in pursuit of progress, which isn't false per se. This tactic might have been a good solution in the beginning, however now when SpaceX has a firm hold and far more concrete idea of the future of the Starship, striking a balance between speed and thoroughness will be crucial as SpaceX prepares for far more ambitious missions, including crewed flights to the Moon and even Mars. As a result, Flight 7 was definitely a well, a mission of contrasts. It showcased SpaceX's impressive engineering capabilities with the successful recovery of the Super Heavy booster, but it also exposed vulnerabilities in the Starship's upper stage. This failure of the Ship 33 is a reminder that even the most innovative and influential companies are not immune to setbacks. And while SpaceX's approach to development and its unstoppable prowess in the industry of space exploration has enabled groundbreaking achievements, it also raised many questions about the company's ability to manage risks effectively. Now, truth be told, there is reason for both hope and caution. SpaceX's vision, or rather Elon Musk's vision of making humanity a multiplanetary species, is definitely inspiring, but bold ideas such as this are not even half of what will allow us to go to space. Oh no, what is even more crucial is meticulous execution. And frankly, with this and the previous flight, SpaceX has shown very little success, and they have progressively been getting worse and worse. All in all, Starship Flight 7 is definitely a step in the right direction on the journey towards space, no doubt, but it is a step that could have been more confident.